Welcome to Unchatted Waters. In this episode, we take a journey across technology and learn how videos can give us an insight into life below the surface. From understanding species in an area or ecosystem, to details on what fishing vessels catch. If you're a fan of surprising discoveries, this episode reveals what we can learn from nature's TV. Welcome to Unchatted Waters, the podcast that talks to the people behind the science. I'm Kirsty Bradley, your host, and I'm excited to take you on a journey of discovery in our new series. Joining me are two great guests. Rebecca Lamb is a senior fisheries scientist with a focus on using remote electronic monitoring, or REM systems. These systems use digital cameras and sensors to collect scientific fisheries data, including fishing activity, catch information, sizes and quantities of fish caught. Paul Whomersley is a principal marine consultant focused on the design, designation and management of marine protected areas. He has a particular interest in sustainable development of these areas and how they're managed by local communities across the globe. Welcome to the podcast. Hi. Great to have you. So let's kick off with the first question. What is monitoring? And why is there a benefit to doing this remotely?
So we can monitor fisheries in a range of ways. So traditionally we use observers by sending those to sea or to fish markets and merchants to collect information on fish length, collect something called otoliths that we can get fish age from. But as we've kind of moved forward, we're using other ways to collect data, and that includes remote electronic monitoring, which includes putting cameras and sensors on board fishing vessels that can then be used to collect further data. So things like GPS can tell us where the boats are, how fast they're going, and from that we can get information on their fishing activity, so where the hauls are taking place and how long they are. And by reviewing the video footage, you can get information on catches, including length information, total numbers of fish caught, and then we can use that to get weights of fish, which can then be used to figure out how much fish is being taken in total.
An otolith, I know we probably put it in our first set of episodes in our first series, we defined what an otolith is, but can you remind our listeners?
Yes, so they're often referred to as the ear bones of fish, and they're calcified bones that they lay essentially rings like you do with trees. You can count the rings on the otolith in order to decide the age of the fish.
So what are the benefits of using remote electronic monitoring instead of sending a human observer on board or to markets?
Onboard observers, they're tied to a single fishing trip and have to be on board for the entire time. They can't kind of come and go as they please, which does mean that it can be a little bit inefficient in terms of if a vessel's steaming quite far offshore, they have to be on board for that entire time. One benefit of REM is that you can kind of skip to the interesting bits, so you don't need to worry about them moving between one place and another. You can go straight to where the stuff's happening that you're interested in. Because REM systems are on board for long periods of time as well, you can capture what we like to call rare events. So species that either aren't caught very often or they might be caught in really large amounts, but sporadically. REM can help capture those because it's a continuous method of monitoring, whereas observers are kind of a spot monitoring approach.
How does this compare with monitoring fish populations in the wild? Because it's not every fish is exploited or harvested.
It's really important to monitor fish populations in the wild to, get an idea of ecosystem health and biodiversity. There's lots and lots of different fish species. We need to understand, their condition and how healthy those populations are. So in the past, we caught fish, we measured fish, we identified fish. But as technologies moved on, we've started using lots of different remote techniques. So underwater cameras, which initially, when I first started sort of working in this area, were dropped down. So they were tethered to the boat, you would drop them down or you would tow them close to the seabed and then monitor the videos. But then as we've progressed through time, we've now started using something called baited remote underwater video systems, which are cameras you can either float as a long line on the surface of the seabed, So the systems we use, they stretch out for 1 kilometre, and there's 5 separate cameras along that line, so 200 metres apart. The cameras are stereo, so a lot of the information can be captured by the videos. Because we get a stereo image, we can collect biometric data. Biometric data being length, which we can convert then into biomass. We identify the species, we count the species, so we can start building up the fish population information from the Broad's cameras.
And I guess in comparison to what Becca's been talking about, it's the fact that they're not disturbed by fishing in situ or in the environment, so you can really understand what they're doing naturally. Is that right?
Yeah, so we don't have the problem of boat noise or human activity in the area, but the thing we do have to deal with is the fact that we've got bait, so we're actually encouraging fish to come to the cameras.
Right.
So what we have to bear in mind is that those fish might not always be there all together, and we're pulling them together. So we use something called max N. So we always count the maximum number of the fish there at one time. So we don't count fish constantly, because we don't know if we're counting the same fish more than once. So we work on a max N, and that tries to do away with some of the bias of having bait in the cameras. So we're not saying we have got hundreds and thousands of fish, because we're seeing so many fish around the bait, smooth out that bias of having bait in the water.
Do we put these out in the UK, or is it in further afield, more remote places like overseas territories?
They're actually really easy to use. So the bruvs that we use are carbon fibre, so they were designed to be used off small ribs or fishing vessels. And so you don't need cranes, you don't need winches, you don't need a lot of equipment to get them over. You can manually put them overboard, you can manually bring them in, so they're really light. When we initially started using them, we used them overseas just because of water clarity and visibility. So around some of the South Atlantic islands and the Pacific islands, you've got 40, 50 metres visibility underwater. And the original design of the bruvs, they didn't have integrated lights. So we couldn't really put them in the North Sea, for instance, where visibility can be a metre if you're lucky. We are starting to use them more in the UK as we develop them further and start adding lights. But again, then we have to look at how the lights affect what we see, fish and other species come to the cameras.
Yeah, I can imagine squid are attracted to light, aren't they?
But then other species are detracted and can get scared away by lights.
Yeah,
so that's
exactly.
The other thing.
Yeah. Great. So while in principle these are really novel, easy to use, simple systems, what are the challenges of installing these remote camera systems?
So in terms of remote electronic monitoring, REM was initially kind of put out in the fisheries world as an enforcement tool, and we still have a lot of those kind of feelings kind of surrounding it as a technology. So when you talk to the fishing industry, it's a feeling of Big Brother and being watched, which is, I can entirely sympathise with. You put in a camera where somebody's working. Once you kind of get over that, you can address that and reassure people that that's not what you're doing. Even getting the cameras in the right place can be quite challenging. If you go around and look at fishing vessels, even all the fishing vessels in one port, no two look exactly the same. And even if you get two vessels that are exactly the same and the layout's exactly the same, you can almost guarantee that the crew on board won't handle the fish in the same way.
Oh, okay.
So where you want to put your cameras, you have to be collaborative and have conversations with the skipper and the crew and figure out where the fish comes on the boat, how they move it around the boat. Because what you want to do is you want to put the cameras where the fish are going to be. You need to figure out whether you can deal with a camera being really far away, which means that the resolution of the image might be a problem, or do you need to get it really close up because you want it to be a really clear image? But then if you need it really close up, is there actually anything that you can mount a camera to? So it can be quite challenging to figure out exactly where you can put all your equipment. And then once the cameras are on board, so there tends to be a little bit of a of a bedding in period. So to start off with, the crew and the skipper will be really conscious that the cameras are there, and which is okay, because generally if they're thinking about the cameras being there, they remember that they need to do something to do with the cameras, but then they'll forget that they're there, they'll become quite comfortable with them and then forget about them. A lot more collaborative than people think it would be as a remote monitoring method.
So you're almost coming up with a bespoke setup for every single vessel that you go on, because everyone's got power supplies in a different place, everyone's got their conveyor belts in a different place, some people don't have conveyor belts. So it's a real, like you say, collaboration between you and the skipper and the crew to then make it as effective as it can be. Okay, so it's the same question for you, Paul. What challenges are there with installing remote BRUV systems, or baited remote underwater video systems? Have I got the acronym right?
Yes.
Yes!
Yes. There aren't as many challenges as what Becca's just been describing about REMS. I think the main challenge is resource for sort of small island communities to deploy the equipment, and finding suitable vessels to get them out to the places they need to be.
An issue with finding the little buoy that you've attached the BRUV to in those remote areas? Yeah, how do you do that?
I would love to say no. The BRUVs that go on the seabed are generally really easy to find, because you have the BRUV on the seabed, so sat on the seabed, just looking at the fish communities with we call it a drop line that just goes straight to the surface, and we have a big buoy on the top. We can take a GPS position of where they are. The challenging deployments are the pelagic BRUVs, so the ones that are in the water column. Because we don't want to have a big boat engine, we put them in for 2 hours. So we call it a 2-hour soak time. As the boat's moving, we deploy them off with a buoy at one end, a buoy at another end, and then we have a radio beacon, sometimes a satellite tracker on one of the buoys at one of the ends. And then we set them free and we go off and do something else. So we generally have an idea based on tide and wind on how far they'll have drifted and in what direction.
In theory.
So we generally head to a mark. We can find them in 10 minutes, which is absolutely amazing. They can take 5 hours to find. So it does really depend, and it's one of those things of any marine research, putting something in the water and leaving it is always a huge risk. I think one of the initial challenges, and one of the challenges, I guess, and opportunities, as I like to be optimistic, is the use of fishers to deploy this equipment. And I think, again, as Becca described, there's some nervousness in fishing communities when scientists turn up with equipment and ask to record things, because they think whatever that information collected is probably going to be used to stop them doing something,
right,
or will affect them in a negative way. And I think that relationship between scientists and fishers is really important. And I think once you have those relationships, you get so much information sort of moving between scientists and fishers, which is really valuable. And I think that one of the challenges initially was getting fishers to understand what we were trying to do and how and why it was important. It comes down to communication and awareness raising. And I think once you've got over that hurdle, the fishers were so keen to be involved in the programs and help take the cameras out. They love seeing what fish were there
beneath the surface,
because they didn't always. They saw the fish they caught.
Yeah,
a lot of them didn't snorkel. They don't dive, so they don't know what is below the surface.
Yeah,
you know. And we got so many questions. Can we get some pictures? Can we get some videos? Can I take some things to show my children? So you develop the information that we collect isn't just scientific. There's another aspect of it for awareness raising, for education, you know, going into schools and showing the videos of what's there and then explaining why it's important to conserve and protect.
Yeah, I really like what you were saying about industry, both of you, what you've been saying about industry and scientists, because I see them as a really important information source. They're out much more often than we can be. they've been fishing for several years, longer than our careers potentially, and we have information of a different type, and then when we come together it's just a really nice kind of bringing all of our jigsaw pieces together and making a jigsaw, that joining of heads to confront a problem. It's really nice that your two methods really bring that to the forefront, so thank you. Okay, so we've talked about how these remote systems and cameras are deployed, what they look like, some of the challenges. So once we've got those cameras out and they're recording video, what happens to the video after we get it back?
So a REM system produces two different types of data. So what we tend to call sensor data, which comes from the sensors, including the GPS information on location and any gear sensors that we might put on the vessel. So that comes in, and we tend to get that remotely because it's quite a small amount of data. Normally 3G, 4G, so the systems have got a SIM card in like a mobile phone would. The video data can be slightly more challenging because that tends to be a lot more data. The systems do have the ability to transfer the data remotely, and we have been increasingly using that, but transferring large amounts of video over 3G just doesn't work particularly well, and it can be because the vessels aren't in port or have signal for long enough between trips, which means that you then don't get a chance to upload the video. So the other option is if you can generally go and collect the hard drives and change a hard drive out from the computer. They're your two ways that you can then get your data, and then what you do is once we've got it all, it then needs reviewing, and generally at the moment that's done by people. So people will sit at a computer, and the first step tends to be looking at the data and identifying where the fishing activity is. So we can look at the speed. If we've got gear sensors, that also helps because we can generally see then where they're hauling and shooting, and we'll identify where all the fishing activity is because that tells us where the video is that we want to look at. Depending on what the objectives are of the data that we want to collect will depend how we review the video. So if, for example, we're just reviewing video for sensitive species bycatch, those species tend to be quite large and they're easy to spot. So we can watch the video quite rapidly, so we can speed it up and watch it like 2 or 3 times normal speed. If we're doing more comprehensive kind of analysis of the video, so we might want to capture information on a large number of fish species, we generally need to watch the video a lot slower, and we'll be watching different parts of the process on board the vessel to collect different information. So we'll need to watch the vessel sort the catch in order to collect information on any discards that they might have, or we'll need to watch them processing the catch to capture the information on the species that they're going to land, get all that information together and then enter it. So it can be quite a time-intensive process to actually generate the catch and fishing information.
So, same question to you then, Paul. So once you've put your bruv in the water, it's recorded the natural environment and the natural fish populations without disturbance. How do you then get that video back? As they're under the water, I assume that you can't remotely access that video.
No, we can't. And I guess some of the remote places that we work and we've been deploying bruvs, we also don't have the option of taking that data off the cameras and streaming it back, because we don't have the connectivity or bandwidth. What we generally do with the bruvs, so we ship a set of bruvs to the remote areas, the island communities, and they are their equipment. So we don't fly in as scientists with equipment. So all the equipment is left with the island communities. So it was one of the things we really had to consider was how, if the communities didn't have the resource or expertise or didn't want to process their data themselves, they would just collect the data on the camera, memory cards, transfer that data onto a hard drive and then post it back to us. And then we would process the data, get it into a format, put it back onto the hard drive, summarise all the information, statistics into a small report, and then send everything back to the island community. So the island community would get a detailed report of their survey. They'd get all the original data, and we also used to send them we still do send them a highlights reel, because that was, I guess, a lot of the information that they then used as education and awareness raising material. Yeah. The other way that we've started moving towards is trying to provide a training course where we can also train our colleagues in these remote places to process the data themselves, Because again, what we don't want is for those communities to be relying on external scientists to do their monitoring. So we want to make them as self-sufficient as possible. So we're now moving to seeing if is the way of providing an online training course that will give them enough information and expertise to do it themselves. With our support, we'll always be there for emails, and the idea is that they can do it themselves, because then it just empowers those local communities to monitor their marine habitats and marine protected areas if they have them.
So we've talked about a lot of different ways that this really impressive technology, has helped us monitor fisheries and natural populations. But how does this fit into the wider scientific landscape?
Generally, this fisheries data is used for stock assessments so that we can figure out if there's issues with the fish stocks and things. You can use the data independently, and it can just be one of the data sources that gets submitted. REM's being used around the world, so it's not just England or the UK that's using it. There's lots of countries that are using it, and there's a movement for REM to become kind of a normal monitoring tool in the same way as sending observers to sea, creating monitoring programs that are a hybrid, so where you use REM to monitor some things and observers to monitor other things. There's things that REM can't do, so you're never going to be able to collect otoliths using cameras because that requires somebody to go and touch a fish. So creating these hybrid programs where you're collecting data from both is I think the ideal solution, and what a lot of people are moving towards.
How do BRUVs fit into the scientific landscape?
Currently, BRUVs they're really complementary to other methods that we've mentioned. So what we're now trying to do is integrate the BRUVs with ongoing programs. Because we now have sets of BRUVs in multiple areas, we've got data being collected in a really consistent way, being processed in a very consistent way from a wide geographical, almost global spread, which allows us to sort of address local questions and start looking at large-scale questions that can relate to climate change, etc., etc. So there's a real local focus, but you can then pull all your information, because it is collected using the same equipment, the same way, and start looking at those really large-scale questions that we need to start thinking about now.
Wow, so local focus with global impact.
Definitely.
You can have that tagline.
Thank you. I'm going to have that. Hashtag.
So I think I want to think about where we're going. That technology has really come on leaps and bounds in the last couple of years. What do you think the future of these remote techniques is going to be?
So, and it's simple things like we used to use standard definition cameras, and now they're all HD. So, there's been kind of small changes that make a really big difference. But I think the next leap forward for REM is going to be the application of artificial intelligence and machine learning. One of the main limiting factors of how much data we can get is the review process, because it's so time consuming. The application of AI could make that really minimal. The AI can be as simple as you can get it to detect when something doesn't look like everything else, through to the aim eventually could be that the AI is well enough trained and good enough at it that it can identify everything that it can see in the video. We're a long way off that. That'll mean that the limiting factor of how much data you can collect isn't how much data you can review. It'll be how much data do we want. So I think that's where REM will go.
Same question to you, Paul. Where is technology going in BRUVs?
We've mentioned sort of our deployments, but from those, the information that's collected, especially in areas which are really biodiverse, so we see a lot of fish species. We always say that 70% of the effort is actually processing the data. Currently, in BRUVs, within a sort of frame, we have to highlight each individual fish, and then we'll measure each individual fish. That all gets put into a spreadsheet with an identification, the length, and then we'll do the same again in another frame. As technology improves, the idea is to move over to machine learning. So AI can does recognise that that's a fish, to the point where it could recognise that it's a fish and it is that species.
Oh, wow.
And it highlights it, it measures it, and it puts it into the spreadsheet. That's kind of the holy grail of where we need to get to. And I think the thing you have to remember is that you don't get all the same fish species all around the world. So you still need that, I guess, that human input to help AI learn.
And I don't think AI will ever completely replace people, because
Never.
But you're always going to want to double check, because once you train an AI algorithm, it's not a static process. You don't go, well, it's trained and we're happy with it. There's a constant training process with AI, because we've not got to the point where it's the best it can be. So it's continuously moving forward. And every time you add more images or you train it a little bit more, it could change the way that the AI then interprets the video. Mm-hmm. So there's always going to be that human element that we want to go, well, it said it saw that, but do we agree that it saw it? So yeah, it's never going to be, I don't think, a complete replacement. It's helping us achieve what we want to achieve.
As scientists, we've always got to have that QA process where even if you do have a remote process for looking at large sets of data, there has to be a percentage of that information that you actually go and check, just to give you the confidence.
You'd do that with a human though, wouldn't you? You check that, okay, we taught you how to ID that fish. Yeah, a tool in our toolbox that we can develop, which is really exciting, and I think it'll be really, like you say, really useful and valuable for this kind of the barriers in this work area. So we're getting to the end of the episode now, and it's time for our Fun Facts feature. For this series, I've been renaming it into a treasure or a nugget of information that you can give our listeners, they can take away, tell others what they've learned on this podcast, and really take it away as a treasure in their pocket. So I'm hoping you've got your gems and treasures with you.
Yes, so I think mine for REM is basically what you see can just be really interesting. One of the most weirdly interesting things that I've seen was a baked potato. And the skipper was very specific that it was a baked potato, not just a potato, which really confused me when I first saw it. It took me a while to figure out what kind of potato-shaped fish I was seeing, which wasn't a fish at all. And I've seen everything from that all the way up to an angel shark. So by putting cameras on board boats and leaving them there, you see some really interesting stuff, which is what the industry tell us is you'd never believe what I've seen while I'm out on my boat, and now we get the opportunity to see it too, and it's really interesting to get the insight.
Harness the curiosity across industry and scientists.
I'm very jealous of the baked potato. We've not seen any baked potatoes on the Brubs. I think
closest is a sea cucumber, is it?
Probably, yeah, definitely. I think for the Brubs, some of the behaviours that we see. We have a set of Brubs in the British Antarctic Territory. Seen videos of penguins diving down and doing some sort of stone picking up behaviour that's probably not fully understood yet. Moray eels and octopus just watching and working out how to get the bait out of the box. So again, just behaviour. We've had them swim behind the actual cameras in the base bars and knock the cameras off. So hooligan moray eels. The really valuable things of the Brubs is it sees things that people don't think are there anymore. So off Cayman Islands, we've had video footage of oceanic whitetips, which are critically endangered species, but people didn't think they were around the island. So actually getting real-time footage of these sort of apex predators is just amazing, and it just makes you realise that they are still there and still need protecting, because if out of sight, out of mind. But actually seeing them again and being able to tell people that they're there and show people, it just reinforces the importance of that. And I think that the highlight for me, so the local communities in Pitcairn Island deployed the Brubs themselves, and we were busy watching the footage of sharks coming up to the cameras. Because we had the volume on, you could hear whale song in the background.
Ah.
And as we were looking at the sharks, just in the background we saw a humpback whale and its calf just drift past. Wow. Just drift past the cameras. So again, you're just watching you're watching what's under the water in awe. It's just amazing.
Nature's TV. I think
Definitely.
There's a lot of people out there, and I'm included, that I just love seeing the secret lives of nature and just
special.
Seeing what they're up to in their own little world without us kind of bothering them. And equally, I enjoy seeing what comes up from the sea as well. So brilliant. Thank you so much for your time. It's been such a great episode, and we'll add some pictures of what we've talked about to the infographic so that listeners can see the kind of equipment. So thank you so much for your time. It's been such a great episode.
You're
Thanks.
welcome.
Thank you for listening. This podcast was made by CFAS, the Centre for Environment, Fisheries and Aquaculture Science. To keep up to date with us, follow us on social media using @CEFASGovUK. We hope you can join us again next time.